I'm going to quickly talk about finding the moment arm in a lever system when we're doing elbow flexion. I'm going to chalk two different examples. One is when the elbow is at 90 degrees, one is when it is not. In both cases, we're going to identify all three parts to the lever system, the fulcrum, the effort force, and the resistance force. So that's the hand, the radial tuberosity where the biceps inserts, and the fulcrum where the rotation is occurring at the elbow joint. Same thing here, fulcrum, effort force, resistance force. So we're going to identify the axis of rotation. That is right along here. Same thing here, but it's along the line that our effort and resistance force are already acting on. So we have a 90-degree angle here. Technically, the formula to find the moment arm is going to be the sine of the angle through the perpendicular angle through the rotation, axis of rotation. In this case, it's 90 degrees. Great thing about that is sine of 90 equals 1. So we don't need it in the formula. That's why when you have 90 degrees like this, all you have to do is take the effort force distance, and whatever that is, that's your moment arm. If this is 1 meter, then your moment arm, R, is going to equal 1 meter. For here, we're going to take this, draw a perpendicular line. A perpendicular line here. I'm going to say this angle is 50. That's what they use in the book. It'll make it easier. So I'm going to find the sine of 50 and multiply that by the distance here of our effort force. I'm going to say it's 1 meter to make. So I know the sine of 50 is going to be 0.766. They said that in the book, and it's really easy just to plug it into a calculator. Multiply that by my easy math distance of my effort force, which is 1 meter, and I'm going to get 0.766 meters, and then I'll plug that into my equation. So if I'm doing 1 Newton of force, and I multiply that by the distance times the angle, sine of the angle, then I'm going to get my torque as 0.766 Newton meters. Where up here at the 90-degree angles, it would have been 1 Newton times 1 meter, and it would be 1 Newton meter. So the angle does play a role. You need more force at this angle because it's more difficult to overcome the resistance here. Because we can see we don't give as much rotational torque as we do when we have that 90-degree angle.